Hi class, here's the video lesson for Friday's class. I mentioned I wasn't going to be in class, so here's the video lesson. I just want to, it's 3.5 collect like terms, and I just wanted to start off with a definition. Remember, I'm trying to build up your mathematical vocabulary. So the word, whenever you see the word simplify, it means to find an equivalent, simpler, and shorter expression. Okay, so um, that's what you're going to end up doing when you're collecting like terms. Okay. Let's talk about identifying like and unlike terms. So if I change my pen color, things that look alike. So this looks alike with this, and the numbers look alike each other. These are just numbers, and I could have circled. So these red things that I've circled, they all have the x's in common, and the two numbers, these are just numbers, and they are like terms. Okay, let's do something similar on the next screen. So what looks similar to stuff on here? Well, this looks similar with this, and nothing else looks similar to anything else, so these are all unlike terms. Okay, if we do it again on this screen, I have this that looks like this, and I have numbers that look like numbers, and these are unlike terms. Okay, so let's do some algebra, or we're going to get into some algebra. So here's the definition of like terms. Terms that have identical variables. Okay. The exponents on all variables must be identical for the terms to be like. So if you have a variable, they must have the same exponent for them to be like terms. Okay, so i.e., x squared 3x squared negative 4x squared. These are all like terms. The only thing different are the coefficients in front of the variable. One other thing that I want to explain to you is this idea of algebra tiles. This is a little bit abstract, but I don't have the tiles here today, but I'll bring the tiles on Monday. There's just an arbitrary length. You'll see when you see the tiles, they have some skinny ones like this, some square ones like this, and then some tiny ones like this. And how they get these measurements is the small tiles here is they are 1 centimeter by 1 centimeter, and what they've done is they've denoted anything red is considered positive and a blue tile is considered negative. And so these small tiles are 1 centimeter by 1 centimeter, and then what they've done is they've arbitrarily made the skinny length x and the width 1 centimeter. So if I multiply or find the area of this tile, it's x times 1, which is equal to x. And then, to make the tile negative, they just make it blue. And then they have these square tiles. So if this is side length x, this is x, this is x, x times x gives you x squared for the area of this tile. Carrying on, you can have what's called a zero condition. So if you have one of each, or you have the same number of each, they can be grouped together to create a zero condition. So one skinny blue tile and one skinny red tile would create a zero. If you had a pair of two of the small ones, that would become zero. And if you had two of the big square ones, that too would also become zero. Okay, so let's take a look at some examples. So if I have 4x, this means I have 3 red skinny tiles, and I'm adding, this is 4x, and I'm adding 3x, and that's 3 red skinny tiles. I end up with 7 red skinny tiles altogether, so this expression would equal 7x. Next example, a little bit scrambled, 4x, 4 red skinny tiles, plus 3 of the small red ones, plus 2x, 2 skinny red ones, plus 5 of the small ones. So then all I do is I just add them all up. 4 plus 2 over here, I have 6x, and then I count up all the small red squares, and I have 8. Okay. let's make it a little more complicated. Remember when we talked about integers, when you think of subtraction, subtraction is also addition of the opposite. Addition of the opposite. So 8x denoted by the 8 red skinny tiles, and then I'm adding 3 of the blue ones because they're negative. Then what I can do is I can group, I have 3 blue ones, I want to group them with 3 red ones to create a zero condition. This creates a zero condition. And what's left over? I have 3 of the red skinny ones left over, and that's how I get my answer, 5x. Let's go to the next example. Okay, 2x, 2 red skinny ones, minus 5x is 5 blue ones. I can only group 2 reds with 2 blues, and I'm left with 3 blues. The blue is negative, so this is negative 3x. Let's go to the next example. I have 5x, so 5 red skinny ones, minus 3x, 3 blue ones, minus 6, so that's 6 of the little blue ones, and plus 3, which is 3 of the little ones. Then again, I want to look for things that I can zero out. So if I match each blue with one of the reds and blues with reds over here, I'm left over with 2x minus 3. Okay. Again, now with some of the bigger tiles, 3x squared plus x minus 2 minus 5x minus 4x. I rearrange the expression to get all the like terms together. 3x squared minus 4x squared plus x minus 5x minus 2. Then I drew in the tiles that represent each one. So 3x squared is represented by the 3 large red tiles, minus 4x squared, the 4 large blue tiles, plus x is the one red skinny one, minus 5x are the 5 blue skinny ones, and minus 2 the small blue ones. Then again, I want to zero out whatever I can match up. 3 reds with 3 blues, zeros. 1 red here and 1 blue here are zeros. And what's left over? 1 blue, negative x squared. 4 blue skinny ones, minus 4x. And 2 small blue ones, minus 2. So that's the final expression there. Now let's try this without the tiles. If you can remember back, you add in elementary school, you often add in columns. So as long as you alternate something with a variable with a number plus variable and number, so I did 6x plus 4 plus 8x plus 3, and then you just add everything in columns like you used to do in elementary school. 14x plus 7. Let's go to the next example. 2b minus b plus 7 minus 8. Again, alternate the letters with the numbers. 2b plus 7 plus negative b minus 8. When you look at the columns here, 2b minus b is b, and 7 minus 8 is negative 1. Now we're introducing the squared component. 3r squared plus 2 minus 6r plus 9r minus 3r squared. So again, you want to alternate, or notice how the first term has the squared exponent on it. The next term doesn't have the exponent, and then followed by the number, if you follow that pattern. So I did 3r squared minus 6r plus 2 plus negative 3r squared, which is from over here, plus 9r, and there's no additional number. This and this cancels out. Negative 6 plus 9 is positive 3, and I'm still left with this 2, the final expression, 3r plus 2. And final example, using decimals, and now using 2 different letters, 0.5m minus 4.5n plus 0.7m plus 4.5n minus 1.5. Again, alternate the letters. 0.5m minus 4.5n minus 1.5 plus 0.7m plus 4.5n. And then we just look at everything in columns. This column here, If you add these two, becomes 1.2. This middle section here becomes 0, and we're left with the negative 1.5. Okay, so that concludes the lesson. If you can continue or do the homework on pages 1 on pages 151 to 153, questions 1 to 12 and 14, and the extension question, if you want to challenge yourself, is question number 15. Okay, and I'll see you back on Monday, and remember, we have a quiz on Monday.